What's going on, guys? Welcome back to another video on this channel. In today's video I'm going to be showing you how you could make a humidity and temperature sensor using this temperature and humidity sensor for the Arduino and using a Arduino. Let's get right into it. First of all, let's talk about what you will need for completing this project. Obviously, you would need a Arduino Uno. Well, not necessarily Arduino Uno. You would need an Arduino of some sort. Right here, I have using the Uno. You would need a way to connect it to your computer. Right here, I am using a USB cable. You would also need a LCD display. Now, in this case, I'm using the RG1602S16:2 LCD display. What that means is 16, so this can display up to 16 letters right here, including spaces, and there's two lines, so total of 32 letters in using this. Now, as you could see here, I have got wires soldered directly onto it. This is an extremely necessary step, otherwise there will not be connection if when you do not solder wires to this thing. So now also one more thing is, see how there's 6 wires like this way, 1 2 3 4 5 6, and 6 like this, and then there's 4 in the middle as empty. Now keep it like this. You do not need to solder 4 wires in the middle here. Not that that will make a difference, just that they will just be not connected to anything. Now you would also need this sensor right here. This is in fact the sensor that is going to tell us the temperature and humidity. So now if you notice here, there's four pins on this sensor itself, and there's 3 pins coming out to this board. Now that's because if you need to buy this kind of a board, so including the board, not just the sensor, as there are just sensors available out there for cheaper. They will work, but they are just more unreliable. As you could see, there is more components on here, and other than the sensors, like there's more components on the board right here and stuff. So please get one with the board, not just the sensor. So those should have 3 pins that are labeled positive, out, and negative. And then obviously you would need more extra wires. Right here I have got male to male jumper wires. This is in fact what you will need. And last but not the least, you would need a breadboard like this one. Now in this case, you could see that this breadboard has 2 separate rails and actually 4 segmented rails. This is one segment, this is another, third and fourth. Now getting one like this one is recommended rather than having one long segment, as this would be better. Okay, so now let's talk about how you want to assemble this. So coming over here to the LCD display, what you want to do here is, now you could see how there's now notice how there is 16 written here and there's 1. So now you want to take 1, and then you want to take 3, and then you want to take 5, these 3 wires, so 1 3 and 5 from here, and then you just want to connect them to one rail right down here on the breadboard, like so. Now make sure they're on a single rail. In this case I am using the rail labeled as negative or minus. It doesn't really matter, but yeah. Then take the second wire, this one, and then put it onto the other rail, so the second rail, that will be the positive rail. And then what you want to do is you just want to grab this wire right here, this 16th wire, and then you want to plug this one to ground as well. And then you just want to take this second wire and you want to plug it in to 5 volts too. Well, the positive rail. And then no, actually no, I lied. Don't do that. Connect this second wire to the 3.3 volt output on the Arduino itself right here, as this is the power module, power section rather, which has two grounds, 5 volt and 3.3 volt. Now connect this one, the second wire, to 3.3 volts, and then you want to take a third wire like this, connect it to 5 volt output on the Arduino, and then connect it to the positive side, positive rail of the breadboard like this. Take a third wire, connect it to ground on the Arduino, and then connect it to this second rail of the breadboard, so the negative rail or the ground rail. And then once you're done with that, take, there should be 3 more wires. Just connect one to the 5 volt rail, or the positive rail in this case, like so. Connect another one to the ground rail of this, like so. And then you just want to connect this to you could connect this to anything. You could connect this to digital pin number 12, just as an example. You could connect this to any digital, or for that matter analog pins right here. And then what you want to do is, here as I saw before, there is positive out and negative. Just put this in here anywhere you want, and then just connect the ground to negative, no, I messed up again. You want to connect the ground pin, the green wire, to negative. You want to connect the 5 volt or the positive rail wire to the plus sign, and then you just want to connect the wire going to the Arduino to the middle pins, like so. And then you should be left with 6 wires coming from the Arduino. So what you want to do with those is separate those out, as they're in 2 separate sections, and then just simply plug them in to the digital pin or analog pin section of the Arduino in it, like so. Now do the same for all of these. So just take one, plug them in, plug this in, right this, then the second one. Now make sure, one thing you want to make sure while you're doing this is that they are in order. So like this, like the pin number 4 and 6 go first, and then there is the 16, 11, 12, 13 and 14, no, 12, 13, 14 and 15, no, yeah, so the last 4 wires should go in the digital pin number 2 to 3, 4, 5, 2 to 5, and then 6 and 7 should be the ones which are going to the digital pin, the ones which are going to these two. So these 2 wires, the fourth and sixth wire. So now there should be 8 for wiring up this display, like, and the sensor itself. Now you should now be ready to go into the code. So let's get right into the code. Alright, so now that we are in the code, as you can see here, this is in fact the code. Now first of all, let's talk about libraries that you will need. So you would need these 3 libraries. These are custom libraries, and then liquidcrystal.h is a pre-installed library. Now if you want to see how you could install these libraries, I have a separate video that will be right up there in the iCard, and also it will be linked down in the description, about how you could install libraries and how you could find them and what errors may occur. So if you don't know about that, just watch that video. Now about these particular libraries, DHT11 and DHT.h, these three libraries will be down in the description as a .zip file, and so would this entire code be down in the description as a zip file, this entire code along with the libraries. Now, so let's talk about how you could get this working. So first of all, this is the DTH pin 12. So you want, this is basically the pin on which your sensor is connected. So in my case, as I said in before, it is connected to pin number 12. On the Arduino, this is digital pin. If this is an analog pin, for example, if it's analog pin number 2, you want to do A2 instead of don't do just 2, that would be considered digital pin. You want to do A2 for making it analog pin number 2. So that's the DHT pin or the sensor pin. Now you want to, this is in fact what the LCD is connected to. So 6 and 7 are the two wires from the separate so the 6 and 7 are connected to the ones which are connected in the set of wires from 1 to 6. These two wires were 6 and 7, connected 6 and 7, and then these are the other 4 wires from the second set of wires. Now you, as I said before, just figure these out, and then if nothing, these two now that's why I said to put them in order, so you could just reverse these if it doesn't work and shows black boxes. Same goes for these, and then you should be good to go. Now what you want to do here is keep all of these, and then now this basically begins the LCD. So we will begin the LCD. So, and this second command would start the begin the sensor itself. Now this will print a message, temp and humidity, so you know which one is which. And then right down here there is a delay. Without this it will glitch out. Make sure there is a delay. You could set this to whatever you want, doesn't matter, but there has to be a delay, otherwise it will not work. Now set the delay to as low as possible, as this is in fact the delay at which the sensor is refreshing itself as sending new data to the LCD and Arduino. Now right here you want to set cursor 0,1, so that will set the cursor to the second line of the LCD. As I said before, there's 2 lines with 16 letters each, so this is set it to the second line of the LCD. Then right down here you could see float h equal to DTH pin DTH.read humidity, bracket open and close. So this means that integer h is going to be humidity, and integer f is going to be temperature. So now right here, this command, basically what this means is that if h or f are pulled off, so if the sensor is pulled off, or it gets cut, the power to the sensor gets cut, or it errors out, so fails, it will print error on both of these. So I will print error, and then now right here, so that's what ISANAN means. It means if not h. So if h is not sending any data or f is not sending any data, just print error and then return. So it will return to while loop, as it will return to here, set the delay, and then it will keep refreshing itself until it gets the data from the sensors back. And so now actually this will not, there is one thing that is missing here. So if you do this, it will just print error on the temperature side, and then the humidity side will pause. So it will not do anything, it will just stay paused. So right here, to fix that, what you would have to do is you would have to do set cursor. You would have to do 7,1. So that's gonna be that the right under the humidity part, and then you want to do LCD dot print, and then you just want to do error, so I will print error on that one too, and then return. That's fine. Now right down here, if you see LCD dot print f, so that is print f, that is temperature as it's said here, and also right here if you see first is temperature and then humidity. So right here you print temperature and then set the cursor to 7,1, so right under the humidity. So and then print H, that would be H is in fact humidity. Now make sure you do not put this in the double inverted commas, otherwise this will not work. It will just print the letter F and the letter H. If you do not put them, then only it will work due to this library that we included, DTH and this one. So yeah, that should be it. Now just click verify to see. So right here I messed up, I didn't put these, so now that should be good. And then once that works, just upload it to your Arduino. And then right here, if you see in the Arduino, look at that, it is showing the temperature and humidity. And so because we set the command, so if I pull these off, look, it just errors out. And then if I just put this right back in, look, it refreshed itself back, and now it is in fact showing the temperature and humidity. And for making sure it works, now if I touch the golden part behind it, you can see the temperature is increasing, as that is going to be that because the heat from my finger, the body heat, is going to the sensor, so this temperature is increasing and decreasing all of a sudden. And now this is also one more thing I want to mention here is this is fully portable, as you could see that the Arduino Uno at least has a barrel plug, so you could just plug in a battery set right here and disconnect this, and just like you could directly connect most of these without using the breadboard, and you should be having a portable temperature and humidity sensor like this one. Now that's going to be it for this video, guys. If you want to see more on how to get the LCD itself working without the sensor, I have a video about that. You could check that out. It would be right up here in the iCard. And also please be sure to subscribe and leave a like on this video, and also comment down below what you want to see me do next using LCDs or this sensor and the Arduino, of course. So yeah, bye.